Guys, welcome to my YouTube channel. Guys, we solved this problem before us. I read the question: determine the stationary points of a function, that is function of x and y is equals to x squared plus 2y squared plus 4xy, and state their nature. So guys, we start off doing that question, and now guys, we come and first of all we write that equation. For us to be able to get the stationary points, we do what we call partial differentiation. And so therefore, guys, I have said that these two equations, xy, can be represented by fz. Now I'm going to differentiate with respect to x first. When I do that, guys, I'll get 2x, because this is a constant. This is now 2x, and here we have a constant and we have x, so we shall have 4y. This one we equate it to 0. Next, guys, we come and differentiate with respect to y and also equate it to 0. After that, guys, we are now going to find y and x, and because this one is like a simultaneous equation, guys, we get our value of x and y, and indeed our value of x and y is going to be, here we eliminate the y, we remain with negative 2x equals to 0, and so therefore x is equals to 0, and also y should give us 0. That's the 0 we are looking for, we have found. So guys, before we continue, for the minimum point or maximum or even what we call a saddle point, this is what we use. Guys, this D is called Hessian determinant. That is for the value of D. And this value of D we shall find, guys, I will show you how we come up with it. And this one represent, guys, we have differentiated once, and now we need to differentiate again. When we differentiate again and then our value is greater than 0, guys, that is a minimum point. If we differentiate again and then our value is less than 0, then we have a maximum point. And guys, when we have the determinant being less than 0, we call that a saddle point. And so guys, let's go ahead now and differentiate once again. Remember, we have differentiated once. Here we are differentiating twice for x and x. So guys, we go ahead, and now after that, before that, guys, we've been able to establish our stationary point by finding what is x and what is y. That is, we have used that simultaneous equation. Now we come to the nature of the stationary point. Guys, as we have said, we differentiate once again for x, that is this value. We come and differentiate yet again. When you differentiate yet again with respect to x, guys, we shall find it is 2. And 2, as you know, is greater than 0. And so, therefore, guys, even though we are saying it here, fx is greater than 0, then we need also to find the determinant to see that it's greater than 0 for it to qualify to be a minimum point. And so therefore the first condition has been fulfilled for the minimum point. Now coming to this other value, guys, we do not use this one, but it's already there. And so therefore, guys, this is now the second order differentiation of this. But guys, we shall be using it when we come to finding the determinant. And so therefore, guys, it's still also important. So guys, let's now go to the second, whereby now, guys, we now differentiate this. We are differentiating y with respect to, that is second order for y. Here we have the y. We differentiate it with respect to x, and we get that solution 4. Guys, now for us to get the determinant, which I'm talking about, Hessian determinant, Guys, we use an equation right here. This is the equation that we use for that determinant. And this is what now will show us whether it's a minimum point or even a saddle point. Remember, as of now, guys, we have found its minimum, but we still need to find whether it is fulfills this condition. That is, determinant should be greater than 0. So guys, we come and now use this equation. Remember that, guys, we have already done that, and we have already done that. So guys, we can now use the D to determine our point, whether it's a minimum or a saddle point. Guys, we come here and we have differentiated twice. That is for x with respect to x and with respect to y. Guys, we have differentiated. Now guys, this is 2 and this is 4. For this one, guys, we are finding is supposed to be -4 squared. What we have done, guys, we have differentiated first with respect to y and then with respect to x. And therefore, our answer comes now to 4. We now square that answer. Guys, when we square that, this is what we are going to get. We are going to have our Hessian determinant as d equals to -8. And guys, now we go back to our condition here. We said for minimum, the determinant must be greater than 0. So guys, we find that has not happened. And so therefore, guys, this point, as you can see, -8 is less than 0. And so therefore, guys, our point is called the saddle point. That is the point 0, 0. So guys, thank you for listening to me. Bye.